And yet that's not what we're buying, that's not what we're installing, right? It's still 80% a matrix switch market. Now why is that? There's two reasons for that. Number one, most AV over IP solutions look like crap, right? They compress the image, they've got a lot of latency, and people don't want to make that kind of compromise, right? Or maybe sometimes that kind of compromise is acceptable, but now as a designer, you got to sit down and think it carefully through. Well, is this much compression okay here? Is it okay there? Am I going to make a mix? It just makes your life harder, right? The other problem is there's no standardization. Every smart guy out there's got his own AV over IP. It's better than all the rest. He totally swears, and it doesn't work with anybody else's either, right? Crestron only works with Crestron. AMX only works with AMX. Extron only shows up at the show when they feel like it, right? So there's no standardization. And that just doesn't work in a world where more and more the IT department is who's controlling the buying process, right? You don't go to an IT guy with an HP computer and say, well, here's my HP printer for sale. That's all you can use, because HP printers don't work with Dell printers don't work with HP computers, right? That's a ridiculous statement, right? But that's how we've been selling AV for the whole time, right? We say, oh, well, you already bought some Crestron, so that's all you can use, or throw it all out and start over, right? The IT department doesn't think like that. They expect interoperability. So SDVoE is here to solve those two problems, right? By making an interoperable standard that offers exactly the same performance as a matrix switch, right? That means flawless image quality without compression or with minimal compression, and it means the same latency as a matrix switch, which is about 1/10 of a millisecond, right? So that way we give you all the flexibility, the scalability of AV over IP, but the performance of a matrix switch, and we do that on a platform that's interoperable between our 51 manufacturers. And it's those 51 members that make up the SDVoE Alliance. This is an independent organization owned and operated by its members, and our mission is to drive standardization in AV and to use that approach to displace point-to-point systems like HD-based-T as the way that we move audio-video signals around. We're gonna drive to a world where Ethernet is the backbone all of the time. SDVoE has been deployed in a lot of places already, in a lot of applications. We've seen it in the broadcast facilities, we've seen it in the home networks, and everywhere that Pro AV covers in between that, right? That means enterprise, that means house of worship, education, it means large venue, rental and staging. Even in the medical space, we see this being adopted. It's very easy to understand. Anywhere that a matrix switch was the appropriate design choice, SDVoE fits in that application. And that's because of this shift that we're undergoing right now in technology that's really fundamental. And if you think about it, the matrix switch has been with us since the beginning of television, right? Like 1930, the first time we needed to switch a television signal, it was on a matrix switch. That's how we connect inputs to outputs with the best quality possible and the lowest latency possible. But in the last few years, we've seen the growth of the product space for AV over IP, and those allow us to use the Ethernet switch in place of the matrix switch. But we're not complete for the reasons that I just told you about. Right? So SDVoE is here to offer the performance of a matrix switch on that simplified Ethernet infrastructure. And it really is simple, right? Every single SDVoE system is the same hardware design. It's an encoder at every source, it's a decoder at every display, and a network in between. That's it. Whether you're building a 2x1 system or 1,000 endpoint command and control, it stays the same. And that's why we say SDVoE delivers matrix switching, which is a function, which is a capability, without a matrix switch, which is that big ugly piece of metal that sat at the center of your designs previously. Now I called the matrix switch ugly just now, I'm sorry. There's a lot good about it, it's not all bad, right? It's been with us for 90 years for a lot of good reasons. So at SDVoE we try to be smart and take lessons from history, right? So the first thing we can learn from the matrix switch is that performance matters. The reason it's what we've been using is because it delivers performance, it delivers quality, and it delivers no latency, and it does it every time reliably. So SDVoE does exactly the same thing. We match that performance. I'll invite you guys, after I'm done speaking here, just go right around the corner here and you can see a demo comparing SDVoE against the matrix switch, and the first thing you'll notice is that there's absolutely no difference in image quality. The next thing we've learned from the Pro AV matrix switch is that control and extending the reach of the control system through the matrix is very important, right? This is why your HD-based T receiver has a serial port on it to control the TV, for example. Right? It doesn't matter how good the signal is delivered, if the TV's off, you don't get to see it anyway. So SDVoE has those same control capabilities built in. Every endpoint can deliver serial, infrared, CEC, USB, even a spare Ethernet channel. All those things are available on the platform to reach out and extend the control network. The last thing I have to mention here is that every good matrix switch really carefully considers audio, right? This is the audio-video industry, not just the video industry. So a top-shelf matrix switch will handle any audio format, from single channel or stereo all the way up to high-res multi-channel. Might have down mixing capability, and maybe even the ability to route audio separately from video. Again, SDVoE has taken the lesson, and the platform has exactly those same capabilities. Any audio format, there's down mixing capability built in, and audio can be routed totally separately and independently from video.
Can you send me that one?
The matrix switch is also very flexible, right? As that product space has evolved, today the modern Pro AV matrix switch is actually an empty chassis ready to have some cards installed, so that the designer can choose, I need some HDMI ins, I want some HD-based T outs, some SDI connectivity, whatever it is. You can mix and match and build up a switch that has just the inputs and outputs that's needed for this particular design, right? AV over IP traditionally has been at a sort of disadvantage here architecturally, because imagine if you have a lot of sources in your rack near the switch. Maybe it's a codec farm or a bank of PCs or cable TV boxes. In a matrix switch, you would plug those in with an HDMI cable, plug them straight into the matrix switch, and then use it for distribution. Right? In an AV over IP situation, traditionally you'd have to take your cable box feed, HDMI into an encoder, and then a network connection to the switch. So you had to add that encoder, that extra piece of hardware, to take up space and power outlets in the rack. It's until recently just been an unfortunate feature of the architecture. But working through the SDVoE Alliance, now Netgear has partnered up with a couple of our other members to get to the market an HDMI card for Netgear's modular matrix switch, modular Ethernet switch, excuse me. So now imagine you've got an Ethernet switch full of 10 gigabit connectivity, 40 gigabit connectivity, and HDMI connectivity. So now you take your cable TV boxes, your codecs, whatever, and plug their HDMI cables directly into your Ethernet switch. And then you use the other 10 gig ports to get out long distance to your receivers, to your displays, etc. The last thing we learned from the matrix switch, of course, is that matrix switch prices never go down. Right? If we look at a comparison of some Crestron digital media gear, an 8x8 switch equipped with 16 HD-based T ports, for example, rings up at over $18,000 retail list price. Right? Meanwhile, I can go to Amazon.com and buy a 16-port Netgear 10 gig switch for $1,300 with free shipping. When you scale that all the way up to a bigger system, 72 ins, 72 outs, that's now a $200,000 matrix switch, compared to, actually that would be a collection of 3 Netgear 10 gig switches connected together, providing 144 ports of non-blocking connectivity, and that would cost you less than $40,000. Right? The savings on the switch are huge, and that's because now we're taking advantage of the scale of the IT industry. Right? When you're a matrix switch designer, let's be honest, the biggest companies in Pro AV are small companies compared to IT. Right? Cisco has an R&D budget the size of our big players, right? And they're constantly driving cost out of these systems and following that Moore's Law price curve down. Whereas when you're a matrix switch builder, you've got a lot of cost to develop these things. Every 2 years they come out with a new set of cards, right? We go from 2K to 4K, and now we got 4K 60, now the next we'll have 8K. And every couple of years those cards get, they're $300 more than last year's cards. So the matrix switch price keeps creeping up, while the Ethernet switch price keeps going down. Now let's talk about things SDVoE can do that the matrix switch cannot. So we can match its performance, but we can actually add features and capabilities because of this Ethernet architecture. And the first one of those is instantaneous switching, right? In general, a matrix switch just can't do instant switching. The best ones are optimized to be as fast as possible. They'll use a freeze frame trick sometimes to sort of trick the mind and make this transition a little smoother. But you're usually looking at around a half a second of switching time for even the very best matrix switches. With SDVoE, because we can take advantage of the way the IGMP multicast protocol works, we can actually cut from one source to another instantaneously. Again, come have a look around the corner at this demo and you'll be able to see it and feel it and operate it for yourself. We can build video walls with SDVoE. Every single SDVoE endpoint has an AV processing engine built into it. That's a scaler, that's cropping, that's chroma and color space conversion, it's frame rate conversion, and all that can be controlled to create things like a video wall, for example. Again, the high-end matrix switch has some video wall capability built in. The first thing you'll notice is, again, we can switch instantaneously, so your whole video wall doesn't go black for a second. But we also have an important mode where we can actually gen lock each of the displays to the original source. And what that means is that each of the displays is also synchronized to one another. Now, if you've ever looked at sort of low-end sports bar class video walls, you'll see that there are often artifacts created. When a shape crosses the bezels and that shape is moving around, you start to notice that that each display can be 1 or 2 frames out of sync with the display next to it. And now when something's moving, you don't get a nice straight line across the bezels. You get this sort of broken effect, right? As this display is a little behind this one in motion or something like that. It can be really distracting, especially with sort of panning shots and geometric content where you expect that geometry to be right, and you see it gets broken as things move. Well, SDVoE doesn't suffer from that because we can guarantee that all of the displays are synchronized to one another. The last feature and piece to talk about is our MultiView compositing engine. Now here's something that practically no matrix switch can do on its own, right? This is the ability to take multiple sources of video, composite them onto a single display. So now that's picture-in-picture, that's your doorbell camera, it might be a collaboration space where 2 or 3 or 4 folks are working together with each of their computers displayed on the screen. It could be a security installation. Maybe I want to have 9 cameras displayed on a single screen so I can monitor them all at once. Well, of course, you can achieve these kinds of window effects in a matrix switch world, but it means paying for and designing in a dedicated windowing processor for every single display where you want this capability, right? And by the way, you're going to have to burn up multiple outputs from your matrix switch to connect to each window processor. So this becomes very expensive, and the designer has to spend a lot of time thinking carefully about where do I really need windowing, because I'm going to have to pay for it. And then furthermore, how am I going to connect it in? How is it going to increase the size of my matrix? And how am I going to manage it? With SDVoE, it's much, much simpler because that multi-view capability is just built into the endpoints themselves. So if you have a 100 display system and you want 100 multi-view displays, it's just a matter of programming. Just tell the receivers that you want multi-view, and that capability is turned on. SDVoE is unique in that we offer true interoperability between these manufacturers. That mees not only does audio and video work together like HDBaseT, but our control is interoperable and our power systems are all interoperable, right? That's what sort of separates us from earlier industry attempts at standardization and error, right? And that means that these 51 manufacturers who delivered over 200 shipping products to the market all work together. You'll notice when you see this demo around the corner, there are 8 different manufacturer products making that demo run, and still using all of the most advanced features of the platform. How do we do that? It's because of our software, right? Remember, we're the software-defined Video over Ethernet Alliance, right? And the software-defined part of this refers to the common API, the application programming interface, that's defined by us and that all of these manufacturers' products adhere to. So what is the API? The API, it's very simple to understand. It's just a set of commands and controls that tell each endpoint in the system what to do, right? There's a command that says route input A to output B. There's a command that says go to output C and turn on the scaler, set it to 1080p 60 output. There's a command to turn on the video, a command to make a multi-viewer, and so on and so on. So it's that software that defines the functionality of the system, right? I told you before, the hardware is always the same. Encoders here, decoders there, network in the middle. And we're going to use this API to decide which one's a video wall, which part of this is a matrix switch, where are the multi-viewers, etc. And then that is what drives our interop. Because all of these devices respond to that API in exactly the same way. That means that audio is compatible, video is compatible, and control. Now we've taken advantage of that API and interoperability ourselves. People would come and ask, they say, I love this SDVoE technology, but can I use it with my Crestron control system? And the answer has always been yes, but you might have to go write a driver to our API to use in your Crestron system. So we decided to make that easier, and the SDVoE Alliance has created our own driver for your Crestron system to control SDVoE endpoints. It's available for free from our SDVoE Academy. You can grab the link right here above my head. It's available for free from the SDVoE Academy, and what's interesting about it is because of that common API, this single driver controls the products from all of the different manufacturers. You don't have to have a specific one for a specific manufacturer. Now, how are you going to keep track of these 200 products in this growing ecosystem? Just last week before ISE, we announced the availability of the SDVoE member product catalog. So that's right there on our website. Go to sdvoe.org, click on products, and you'll be able to sort and filter and understand who's building what components in this ecosystem. And then of course you can get connected with those manufacturers if you want to learn more. So how does SDVoE benefit you guys, right? As I see the AV world, I kind of break it down into three groups, right? There's the installers, the system designers, and the system owners, end users. And each one of those groups has its own unique way that SDVoE benefits them. Right? For installers, it's really about simplicity. Right? And remember, think about the HD-based world and cable lengths. Right? There's a secret decoder ring. You have to plug in, what's your resolution? What's your frame rate? Are you using the compression or not? What kind of chroma are you using? What kind of cable is this? And then it spits back an answer, right? Well, this one's 35 meters. Okay, that format can go 70 meters. Here's one that does 150 meters, well, at 1080p and below. But it can be really challenging in the install world when your job is to get cable from here to there through what kind of shape of conduit path, I don't know, to try and also keep track of which signals are going to run down here and what cable length is maximum allowed. With SDVoE, it's very simple. We didn't invent anything in the physical layer. We're using Ethernet. It's 10G base T. And the IEEE spec says 10G base T works on Cat6a at 100 meters. That's it. Doesn't matter if you're sending 480p or 4K 60, that has nothing to do with it. IEEE says it works at 100 meters, that's the end of the story. Not only is that easy for the AV installer to follow and understand, but that matches what your certified cable contractors expect, because they're used to building Ethernet networks, and they know that Ethernet is a 100-meter limit, so they don't have to learn to rethink how they design cable infrastructure. It's 100 meters. For designers, the benefits are a lot about flexibility, right? Bidirectional Ethernet ports means that you don't have to count up your ins and outs and be very particular. You just need to know how many overall IOs do I need. We've all been in that situation where I need 9 ins and 7 outputs, and I wish I could buy an 8x8 switch, but now I have to buy a 16x16 just to get that one extra input. Right? In the Ethernet world, if you need 16 ports, you buy a 16-port switch. You need 24 ports, you buy a 24-port switch. A little easier to count. That simplified hardware architecture I talked about before, I think I've mentioned it twice. Encoders on the sources, decoders on the displays, network in the middle. That's it. Now, as the system designer, you don't have to spend your time, carefully thinking about how will I connect the matrix switch to the windowing processor, which ins and outs am I going to use here, where do I need to add the scaler. You can move away from that, have a standardized hardware architecture, and spend your design cycles thinking more about user experience and thinking about how it's going to be presented to that final user, which is really what these systems are about, right? And then interoperability gives the designer great flexibility because it means you're never locked into a single manufacturer's catalog, right? Maybe your favorite SDVoE manufacturer is Christie, and you've designed a great system with microtile LEDs built in and with Christie Terra transmitters, but in that one room you just really wish you had a wall plate. And Christie doesn't have one in their catalog. Well, Aurora does, and it's an SDVoE product too. So now you can build your all Christie system and then grab this one product from another manufacturer that suits your design and plug it right in and know that not only is it compatible and interoperable from an AV perspective, but from a control perspective, there's even no difference. You don't need to do anything special, make exceptions for this other manufacturer's gear there. It's all just your SDVoE platform. For system owners, there's a lot of money to be saved. You know, a lot of times, especially in larger and larger systems, there are real CapEx cost savings. It's just cheaper to buy in the first place. But over the long term, SDVoE saves operationally, right? Your users are accustomed to a matrix switch experience, and SDVoE is going to deliver that. Nobody's going to have to be worried about, oh, well, yeah, this compression looks okay now, but what if I change my PowerPoint slides later? What if the big boss, the CEO, is giving his talk and some artifacts pop up on the screen? Because you know that's when a problem will happen, right? It's only the important presentations that ruin it. And so your users have confidence, and they don't need to be retrained much because the system's going to operate just the way they're accustomed to, right? Meanwhile, the software flexibility I talked about, the way that software defines these applications, that's a great long-term savings too. Because we all know what really happens, right? You design a system, you install it, and the user's happy, they like it. But 6 months, 12 months later, they call you up, they say, you know, I'm really happy with the system, but I wish that in room 3 we could have collaborative, you know, work. I'd like to put 4 people's computers on the screen at once. Can I do that? Traditionally, the answer is, well, yes, we can do it, but I'm gonna have to design some new things. I'm gonna take out some old hardware, we're gonna have to replace it with new. It's gonna cost a lot of money and some time to do it, right? Sometimes I'm sure the user says, okay, and they spend the money. But I think a lot of times they say, oh, you know what? Sorry, never mind. You know, the budget's already been spent, and we'll just live without it. And then I think what happens is that room starts to slowly fall into disuse, right? Because now the room doesn't quite do what they wanted it to do. Right? With SDVoE, that's a very different conversation. Hey, I'd like to add some capability to this room. The answer is, okay, we need to send in a programmer to just change a little bit of the programming for that room, and now we've added functionality. And that might be functionality as big as, you know, adding a video wall where there wasn't one, right? Adding a window processor where there wasn't one. This can all be done just through software instead of really expensive and time-consuming hardware, right? And finally, the convergence of infrastructure is a big savings for end users, right? Today, you have an HD-based cable infrastructure, and you have an IT network cable infrastructure, and they're totally separate, and they both have to be managed and maintained, right? And that takes resources, it takes money, right? Well, as we move to this SDVoE world, it's now possible to converge those networks and just have a single Ethernet infrastructure that's responsible for your IT data traffic as well as all of the AV. And now that's just one network to maintain and manage for that IT group. So here we sit at the edge of a really exciting and sort of final transition for Pro AV. And it's very easy to predict because all communication technologies go through the very same evolution over time. And it looks like this. Right? Any technology for communication starts with analog signals. Right? For us, that was component, composite video, S-video, VGA, and so on. Right? I like to draw a parallel to the telephone network. It's easy to understand. Right? When the telephone network was analog, that was people with little tiny fingers plugging in patch cords at an operator bay, you know, to connect my house, literally, to make a circuit to your house, and now we can talk on the phone. That was the original matrix switch, sort of. Eventually, the analog technology gives way to digital as those electronics become sophisticated enough, and digital gives us the advantage of being able to transmit over long distance without any loss in quality. Right? For AV, that's HDMI, DVI, and eventually HD-based T. And the phone network, that was the PBX matrix switch networks of the 70s and 80s. Next, the digital signals start to become packetized and start to move over networks like Ethernet, right? And that gives us the scalable and the flexible advantages of that packet-based architecture. So again, here in AV, that's kind of where we are now, when everybody here has some kind of AV over IP product, right? Something to move the bits over the network. In the phone system, that was the voice over IP revolution in the 90s, early 2000s, 20, 30 years ago, right? Now the next phase that we're just getting to in AV, and that SDVoE is here to drive, is the move away from this focus on core technology and on products, and into a focus on platforms, software, and user experience, right? So think about buying a telephone today. If you're gonna go to the store and buy a telephone today, what's the first decision you're gonna make? He wants to make it smaller. I don't think that's your first decision. Do you want an Android or an iPhone? That's your first decision. You didn't even consider it because you already know your answer. Are you an iPhone or an Android guy? Android? There you go. Why do you choose that? Because you like that software platform. Because you like the apps and the experience that it provides you. Okay. And that's the way we now think about that kind of technology decision, right? First, we're choosing the software platform, and then after that, now that you've chosen Android, you're going to say, okay, I like a small one. Let me go find the smallest Android you can find, right? The hardware comes second, and that's where we've got to get to in AV. That's what SDVoE is here to drive. That's why we've got this interoperable platform based on software, so that now we can focus more on creating user experience instead of having to worry about all the little fiddly bits of the hardware all the time, right? So that is why we say SDVoE is the matrix transform. So thanks everybody. Enjoy the rest of your day. Safe travels home, and goodbye.
That's it. Yeah. Well done.